Hello, so I thought I would shoot this little video to sort of streamline taking a look at what I've been doing this year in robotics and maybe kind of help explain things and just make everything a little bit easier for everybody. But I thought I'd start first with one of the big changes this year. Normally we would be using a board like this, which is the Teensy, and then a Patton robotics board, okay? And this year, because of the fact that I have students that I didn't know when they were going to be arriving, where they're coming from, who's running remote, it's really difficult to get this board everywhere in the world. Sometimes it can be delayed weeks, sometimes it just costs too much. This board, however, is available everywhere, and so anybody who's actually in another country taking the course can buy one of these boards in some sort of kit pretty much anywhere. But there's some serious downsides to this, and it's taken quite a bit of alteration in the course to make it fit. The biggest difference is you can see this one here has an awful lot of I/O, input-output, as well as powers and grounds. Now this may seem sort of trivial, but when it comes to hooking up a circuit or designing something or displaying something, this particular board generally only needs some kind of a jumper wire and then whatever device you want to plug into it, and then it makes it so it's much more robust and the students can get their experiments done without a lot of wiring hassles. So it tends to reduce the debugging and the errors. Whereas this board doesn't really have any way of doing it. They make things called shields, which do snap on top, but then you can't do multiple things. You have to start stacking shields on shields on shields, and it gets to be really expensive, and it also tends to tie up I/O ports. So we have to do everything with a breadboard. And we did normally breadboarding with this, but this time we have to do everything with the breadboard, all the individual circuits, all the experimentation. And although this is kind of cool and rewarding, it is slower to get it done. And it also has a few more issues with debugging, especially with remote learning. But we're getting there, and it's working quite well, but definitely has limitations. There's other big differences, too, when you get down to it. This guy's got a math coprocessor. This one doesn't. This one has a lot more memory than this one does. This one's able to do much more complicated calculations than this one. And this guy, of course, because of its layout and its switches, will run a robot much nicer than this one, which requires external wiring and switches, which can be problematic to get it to go. But that being said, hopefully this is a one-year event, and we'll be back to this guy next year. I might continue to use this one as an introduction. It is nice in the fact that it's cheap, easy, and robust for doing some simple stuff. But it does start to be more complicated when we get into bigger circuits, and I would not really want to use this in a robot. So that being said, let's go down to the course itself. I'm going to choose arrangement 8. That's my border students. I got it's a larger class with a lot of diversity, and so it's probably a good one to look at. Just in summary, if anybody wants to see any of the recordings, I try to record all my lectures. They're going to be here, recording for recent synchronous, and you can look at any one of these and see. This one, by the way, was the one that Tom was in observing my course, so it's an interesting one to check out. Going along, all the standard stuff is here. Code examples. These are handy. I put these up here if there's a particular issue with a module. A student could click on it, and then it'll become a fully functional example that we can copy and pasted so they can see what it should do if everything's working right. I also have here in-depth videos which are independent of lecture. So these go into a particular subject in great detail. Some of these are as long as 30-40 minutes, so I don't, these are not standardly looked at, but if a student is having any issue, they're certainly available, and they tend to cover one particular subject, for example, if, else, and else if. Then if we go down a little farther, I do have my online class code, so anytime we do something in class, the code that was developed in class during that class is uploaded so that the students can copy and paste it after that class if they have any issues or questions about how to make something go. Looking at an individual class, I suppose we could start first with the pacing guide. Mine is different than probably most if you look at it. I did break this into 3 basic units. I did this in hopes that moving forward, if we end up switching to a 7-term year, I'm looking at this as individual terms. I would love it if a student, for example, who had AP Computer Science may not even need to take Unit 1. They could simply jump into Unit 2 or Unit 3, and it might be possible for a student who isn't so much interested in the independent work, just wants the experience, to take a 1 and a 2. So I like this idea of being able to break this up and make it customizable. It's even possible a student could take a Unit 1 over the summer, as we did this past year. Much of that material happened in the summer. But that's looking ahead. The way it works is I have individual modules. My aspiration was that students who wanted to go faster could simply do that by getting ahead of class and then allowing for more time for invention work. What actually ended up happening, which is just as cool, but not exactly what I had planned, is those students that were really motivated when they got done with, say, for example, Module 6, they just ended up expanding upon Module 6 and doing cooler things, you know, making more advanced lighting displays and turning in more elaborate work. They got creative, which is fine. I had originally planned on having kids go quick and having creation at the end, but again, those students that are just sort of inclined to do this seem to be expressing their creativity right in the middle of an individual module. So as it turns out, most students are just following this track, and I don't have any students actually that are doing an accelerated track. So if we actually look at an individual module, they're laid out, they should stand alone. So for example, if I just choose one, what we have here is sort of this pyramid pattern. I try to follow it through. The base of the pyramid is going to be the introduction of concepts and perhaps a mentioning of reviews that need to happen. Each introduction of a concept has its own individual video. Okay, or videos. So you might want to see, for example, click on this one, you learn how to do void functions. Click on this one and it has an elaboration on loop structure. And then ultimately, once you go through the what would have been traditional lecture material, there ends up being a challenge where they have to put these things together in a unique way. And then that's explained actually in a challenge video. So I show them what I want to see as output, but I don't actually explain how to do it. And then they submit that challenge here. Every so often there is homework that has a lot of written work. For example, I think it was this one. Yeah, so in this particular case, there was no additional building. It was, we covered basic math, we covered manipulation of strings, and then the actual homework itself was predominantly textbook based, and then they had to turn in several worksheets and written work as opposed to a particular project. So hopefully that kind of gives you a taste of it, and if you have any questions, don't hesitate to ask. I'll give you guys permissions to access this, and I'm looking forward to your input. Thank you so much. Bye.